Hi folks, Joseph Kursky here with you to talk about exploring the world's population with the NASA SEDAC CIESIN Global Population Estimation Web Mapping Application. Now that's a big mouthful of words, but it is wonderful. Hang with me. A wonderful new web mapping service from our colleagues at NASA SEDAC, which is the Socioeconomic Data and Application Center, and CIESIN, which is the Center for International Earth Science Information Network, a research center within the Earth Institute at Columbia University, provides the educator and the researcher with an incredibly valuable, easy to use, and fascinating tool to examine the distribution and demographic characteristics of the world's population. What's not to love? I've been a great admirer of the folks at SEDAC and CIESIN since my days going way back to the U.S. Census Bureau and continuing on to the U.S. Geological Survey. I write about these good folks frequently in our data blog on spatialreserves.wordpress.com. And this population service that they've created is the latest in a series of data and tools that can be used in multiple ways and at many educational levels: primary, secondary, technical and community colleges, universities, lifelong learning, and settings, formal and informal. Once you access the web mapping application, available by the way without logging into anything, available on any browser or device, you can examine global population distribution. Through toggling the maps on the right between country boundaries, road map, and terrain, you can examine the relationship between the distribution of population at scales from local to global, and the relationship of the population density and amounts to terrain, landforms, climate zones, river systems, coastlines, and many more. You can also view a layer called settlement points, which come from the service that's listed here. And you also have the option to dive deeper into the population data by accessing the polygon, circle, or point tools on the left side of the map, as shown here. Note that for 2010, you also have even more detail on the age breakdown. Now, the point buffering tool allows you to obtain population data for circular areas of the exact radius that you choose, as I do here for Mumbai, India. I obtained the latitude and longitude, by the way, for Mumbai by accessing ArcGIS online. And I went to map and I used the measure point location tool as shown here. Here's a screenshot of my point buffering tool, and the results of my point buffer are shown here. Folks, I can run the same procedure for other parts of the world, or simply use the polygon or circle tool, and the map holds all of my areas until I clear them. With these areas now, I can then compare the number of people, age of the population, and change over time. Which areas of the world contain the fewest people? Is it southern Algeria in the Sahara, as I investigated here, or is it northern Siberia, or central Australia, or some other place? Why are some areas experiencing a high rate of population growth, and while other areas are experiencing slower rates of growth, and still others are decreasing in population? What are the implications, societal, natural resources, natural hazards, etc., of growth and decline in these areas? Now wait, folks, there's still more. One of my favorite tools as a geographer is population age pyramids. I mean, what's not to love? This mapping service provides these as well. For example, see the older population predominating on the Great Plains of Colorado. This same pyramid is shown at right here. But at left is the data for roughly the same geographic area in the southeast part of the Denver metropolitan area. The numbers in Metro Denver are much higher, thousands in fact, in each age category versus only a few dozens of people on the Great Plains. But also the age structure is much different, with 30 to 50-somethings raising kids in Metro Denver and not as many people over 65 or not as many 20-year-olds. What do these neighborhoods look like? You can change the base map to imagery, zoom in, and find out. Well, where are the 20-somethings? I look at neighborhoods near, for example, light rail lines in central cities or college towns. You could look at military bases, for example. Here I'm examining Fort Riley, Kansas, not far from the University of Kansas, Rock Chalk Jayhawks. A large military base is Fort Riley, and note the age structure and also the slightly higher number of males than females, although they are pretty similar in number, males and females. But fascinating to look at these patterns. One of the key concepts when teaching with web mapping applications or any sort of digital mapping tools, folks, I'm very passionate about the following, as you probably know from watching other videos and blogs of mine, is where did the data come from? Don't just accept it because it's online. Don't just accept it because it's a web map. No. Let's look at the metadata. Let's find out who created it, when was it created, how often is it curated, what scale was it created at, and so on. So helping researchers and students get into the habit of examining the metadata. The values for this mapping service are calculated using zonal statistics. You could read more about zonal statistics on 1 kilometer rasters from the gridded population of the world, GPW version 4 data described here. Now folks, the GPW data has been refined, curated, and is updated with the highest attention to quality and detail with an expert staff of statisticians and rigorous methods. Now sure, it's not perfect, but it is one of the most valued and respected data sets on the planet. The age data specifically references the base demographic characteristics data set shown here. Another way to focus attention on the data and methods is to examine the mean area of geographic units that is available on the right side of the mapping service. This clearly shows that the data collection units are different for central Kazakhstan, for example, than for, say, Vietnam. Note the settlement points layer referred to above are there for reference and are not used in the zonal stats calculations. Okay, so these places are just to provide you with reference, like where is Warsaw, where is Berlin, etc., where is London. Okay, this web mapping application, folks, I just can't say enough good things about. It fits nicely also into the other web mapping applications that I describe here. Now, I just invite you to use these tools. Folks, use them. They're available. They're at your fingertips. They're incredibly wonderful to teach about the key resources, the key issues, the key concerns, the key current events of our 21st century world. Population, natural hazards, oceans, climate, energy, biodiversity, and much more. So this is, again, the CIESIN SEDAC World Population Global Population Estimation Web Mapping Application. I know that's a big mouthful of words, but I invite you to go and check it out for yourselves and ask questions and encourage your students to ask questions. And for those of you that are researchers, use this as a research tool. Thanks.